All right, I wanted to do this one differently. Read it all the turnout parts in one section, then we'll move on to subpart E. Track Safety Standards Compliance Manual, Chapter 5, Class 1 through 5, April 1st, 2007. 133A. The turnouts and tracking crossing of the fastenings must be intact but maintained so that it may keep the components securely in place. Also, each switch, frog, and guardrail must be kept in free of the obstruction that may interfere with the passage of wheels. Guidance. The several types of fasteners, which include the reinforcement straps, connecting rods, rail hold-down clamps, braces. For more extensive compilation of the fastenings and fasteners listed, the effective codes in Statute 213-133-01 and 213-133-14, where the fastenings are loosened and missing, inspectors should cite the railroad using the defective code 213-133-20. The turnout track of the crossing fastening is not intact with the maintained. In addition, where the fasteners are loose and missing and there is an apparent contribution condition, e.g. the large section of cast is broken within at the grade of the rail crossing inspector should include the description of the contribution condition in the inspector's report. 133B. The class 3 through 5 should be equipped with the rail anchoring through on each of the side of the track crossing the turnout. The restraint movement affecting the position of the switch at the point of the frog for the class 3. The paragraph B is effective in September 21st, 1999. 133C. Each flange way of the turnout of the track crossing must be at least 1.5 inch wide. The guidance for the turnout of the track arrangement consisting of the switch and the frog extending from the point of the switch of the heel of the frog. The arrangement allows the engines of cars to pass through one track and another because of the operating movable parts of the lateral thrust. The fastening to be placed in tight in the sound condition of track crossing the diamond and assembly of the assembly uses the two tracks intersecting a grade of the permitting with the track or on either track to cross the rails or other than may consist of the four frog connected with the short rail. The plant manufactured diamond because there is an impact with the crossing is subjected with the essential the fastening to be in place with a tight and sound condition in each of the switch and the frog guard rail must be kept clean and free of obstruction. Anchors on each side of the turnout crossing through the depth of turnout is required in class 4 through 5 and class 3 track requirement is effective in September 1st, 1999 and determining adequacy for the anchors on each side of each of the turnout and crossing throughout the turnout. Inspectors should determine the capability of these devices. Restraint rail assure the proper fitting of the switch points and prevented the irregularity. Ties and timber switches crossings must be sound condition, well tamped, and the road bedded with adequate drain. Flangeways of the turnout and track crossing must be at least 1.5 inches wide. Turnouts and track crossings must be walked to measurement made before they can be included with the Form 96 with the unit inspected. All right, moving on. 213-135 switches. The 135A. Each of the stock rail may securely be seated in the switch place, but care shall be used to avoid kiting the rail over tightening the rail with the braces. The guidance. The track safety standards under Statute 213-135 specify the requirements of the switch restraint movements and fit each of the stock rail must necessarily be seated with the switch plate. Various conditions such as the loose braces, hanging ties can cause the stock rail to become unseated in these situations. Inspectors should cite the railroad be defective in statute 213-135-01. Alternatively, a stock rail can be unseated if the braces are over tightened during the maintenance. In these situations, inspectors should cite the railroad in defective statute 213-135-02. 135B. Each switch point shall have the in stock rail properly with the switch stand in either of its closed position to allow the wheels to pass over the switch point. Lateral vertical movement of the stock rail and the switch blade or the switch blade and the tie with non-adversely affect the fit of the switch point to the stock rail. The broken crack of the switch point are to be will be just subject to the requirements of statute 213-133 except for the remedial action of C, D, and E require the unit use these joint bars. The joint bars cannot be placed due to the physical configuration of the switch. Remedial action of the B will be governed and taking into account any adding the safety provided with the presence of the reinforcement bars on the switch points. Guidance. The paragraph recognizes the existing reinforcement bars, straps, and the switch points on the joint bars cannot be applied with certain rail defects as required under statute 213-133A and 2 because of the physical configuration of the switch. In these instances, remedial action B will be governed and a person designated under statute 213-7A will at least the 1 year supervisory experience in the track maintenance will limit train speed and so that none not the exceeding 30 miles an hour is the maximum allowed under the statute 239A. The appropriate class of the track, whichever is lower of the course of the person, may exercise the option of 213-5A when it's appropriate. Section 213-135B addresses the crack in which the switch rail point or the rail reinforcement straps acting on the surrogated with the joint bar switch point is not cracked and only the straps are cracked. Then an appropriate site to cite the 213-135B and the inspector should cite the appropriate defects of 213-133A. Turnout and track crossing generally. Normally minor cracks in strap are the major concern, however the strap is fully broken causing the other problems loosening switch clips switch clip, or etc. Then 213-133 would be appropriate. If the straps and switch point rail are both broken, then there is unprotected rail breaking, and inspection should be cited with the appropriate defect on the statute 213-133. Most industry calls the 430 calls for 4 3/4 of an inch opening between the switch point and the stock rail, measured at number 1 switch rod, and components wearing loss motion would result with the problem. Elongated switch and rod holes encountered with the switch rods may be adjusted with the clip and adjustable sides, jaw clips, rocker clips, and etc. Adjusting may also be accomplished by the switch standing depending on the design and assembly. In some cases, loss of motion may be compensated with additional properly designed shims between the switch clamp and assembly with the switch rail. When the opening was substantially left with the standard dimension, wheels can still pass through the switch intended without the back of the wheels to make contact with the inside of the rail head on the open switch rail. The interaction can cause undesirable lateral pressure against the switch rail. The pressure can be contributed to the broken heel bolts and caused by the crack of the broken switch clips. Broken switch crank and cross pins in extreme circumstances with the cross loads point under the movement because of the transfer of lateral loads throughout the switch loads. In circumstances, inspectors should make an extra effort to determine the condition of the all affected components and the amount of throw in one of many of the factors. There must be also to take into consideration to determine the railroad compliance in statute 213-133, 213-135. Based on the above, make sure that the switch points are fit snugly against the rail, and when the switch is thrown on either position, appropriate request for the railroad representative operate the switch and test for loss motion and loose connections. The Appendix A. The appendix of the American Railway Engineer Maintenance Way Association Portfolio Track Work Plans contains the following split switch terms: split switch unit with a uniform riser, split switch with in which the switch rail has a uniform elevation riser plates for the entire length of the switch, therefore not having the heel as a slope pointing the rail being run off at the back of the switch and the closure of the rail. And also split switch with a graduated riser, a split switch in which the switch rates are gradually elevated, meaning the gradual riser plates until they reach the required height above the stock rail, therefore having heel slope. The heel of the switch point is higher than the stock of the rail, and the heel joint of the uniform riser layout of the graduate layout of the switch point is the same elevation of the stock of the rail, mixing the unfamiliar riser of the graduated riser plate for the same switch, which, while not specifically addressed with the track safety standards, can cause undesired stress in switch rails. Closure rails, inspectors should make a note that in intermixing the switch plates and turnouts have a higher amount of traffic. 135C. Each switch rail may be maintained with the outer edge of the wheel tread cannot contact the guide state of the stock rail. Figure 25 shows the stock rail with the outer edge of the contact with the worn switch rail with the worn switch plate. Guidance: the inspector's seating of the stock rail and the switch plate to ensure the outer tread of the wheel cannot engage with the gauge side of the rail to grease the lines of the slight groove of the rail with a slight angle on the tread of the stock rail provided with the inspector with the clues with the wheel and the rail interface. The marks can be found when the areas of the tread transition from the switch rail to the stock rail. When the found, the inspector should closely examine the gauge inside of the stock rail to make sure the outer edge of the wheel tread are not contacting the gauge side of the stock rail. As shown in Figure 25, the type of the defects can occur with the worn switch rail and switch plates remaining in place after the stock rail has been renewed, causes the switch rail to drop down on the same level in the corresponding stock rail. The danger associated with the conditions possibly with the outer edge of the wheel and the contact gauge side of the stock rail during the trailing of the movement through the switching, therefore the turning over the stock rail. Other items of the item that can cause the stock rail to be higher than the switch point include the improper surfacing, cross-tie condition defects, and loose rail braces. 135D. The heel of each of the switch rail shall secure to the bolt, and each of the heels shall be kept tight. The guidance: at least the two tight bolts in each of the required to ensure the heel of each of the switch rail is secured for the purpose of determining compliance to statute 213-135D. Examining the heel block and the passing of the bars in the absence of the heel block, which is known for the floating of the heel block, examined and the assembly. The heel joints were considered to be normally joint. Only one bolt per rail ended with would be required in the heel of the Class 1 track. However, the heel joint function of the different manner with the normal track joint. The heel joint serves as a pivotal point for the rotation of the switch point. It helps maintain the proper horizontal, vertical, longitudinal fit of the switch point against the stock rail. One bolt of the per rail ended up in Class 1 track, and the heel joint does not provide with the redundancy. Loss of the single bolt of the rail end of the heel joint could have the serious safety consequences. Some railroad heel joints have many of the 6 bolts in the higher the track of the classes. Typically, when the railroad plans the field weld, they do not drill the middle 2 bolts in the rail or 6 hell joint bars. This practice provides at least 2 bolts in one of each of the rear end of the heel and satisfactorily secures the assembly. The switch heel assembly with the joint bars also perform the function of the joint. As such, with an improper joint bar, the heel block and the inspector should cite 213, 121 rail joints. One example, the improper joints installation of 6-hole joint bar where the 5-hole bar or design should be used with the deviation of statute 213, 121 because it is improperly designated bar application for that become difficult to throw the switch and may cause gapping. 135E. Each switch stand and connecting rod shall be circularly fastened and operable with excessive loss of motion. For the operated with the switch stands with virtually all types of rotary motion imparted with the vertical spindle. The standing of the person operating with the hand lever is translated into practically linear movement of the connecting of the rod right angle the combination at the end of the swing handle between the standing of the attached crank used unless the crank of the integrated with the spindle of the casting during the manufacturing the separate pieces that must be joined to the crank attached with spindles in one of 2 ways. They may be determined with the thread operating side of the spindle. The cracks may be fabricated with the square, the rectangular smooth opening of the one at the end moved from below up onto the spindle, having the similar cross section and position when it can be secured in place and horizontally inserted with the cross that simultaneously engaged with the crank with its spindle. For easily reference the discussion of the first case of the reference case referred to the Type A. The second class of the Type B, the undesired decoupling of the connection rod to the switch hand can be occurred with the Type A, with the both attaching the connection rod with the threaded handbrake, and that comes out in the Type B, the separated with the crank and spindles can occur with the absence of the cross pin. Either instances could result in gapping closed switch points under the train movement unless some other devices in place physically restrain the points. Type B switch stands may at times have plates likely arrangement of the sheet metal suspended from the head block of the timbers beneath the assembly. The device generally shows the U shape that commonly referred to as the safety plate. The function of the plate is twofold. 1, restriction of downward movement of the cranks on the spindle should cross the pin and be absent so the crank does not completely separate the spindle. 2, the vertical unrestrained crank from sliding down the spindle enough to permit the connection rod enough to display space below the bottom of the switch and stand to move up lug off the crank. Therefore, been caught cases where the cross pins have been fractured. The plate itself is deformed so that the downward placement of the crank was sufficient to enable the connection rod to clear the crank lug with the contacting base on the stand that leads to the decoupling switch of the standing with the connection rod. Inspectors must constantly bear in mind the aspects of the switch stand performance that are critically functionally safety, the discussion concentration on that region of the mechanical linkages between the switch point and the switch stands that may become difficult to observe the course of the turnout inspection. There's several different types of styles of Type B. The switch stands that may be used in the main track of the yards in the railway industry. These models differ in manner or ways. Nevertheless, the rely on cross-pin restraints of spindle crank of the sub-assembly. They also have vulnerability to uncoupling the switch stand's connection rod. A turnout inspection must include the examination of these hard to see parts even. 135F. Each throw lever shall be maintained so that it cannot be operated with the lock or keeper in place. Guidance. The inspector must examine each of the switch and lock of the keeper to see if the type of the switch or the stand internal toggle when the hand is thrown all the way in either position to hold the switch point A against the stock of the rail. These type of the switch stands are used other than the main track and often are semi-automatic design, whether they is trailing the turnout or while the switching is incorrect. Initial force at the point over the final throw is completed with the internal tightening action switch stand. By designing application reference, the switch stand might not have a lock keeper over the main track applications. There's a concern associated with the type of the switch stand retrofitted with the S-shape, the strap bolted with the welded 1-2 flanges with the throw level stop. The bolt has been proven ineffective with preventing rotation over the strap baited weld placed on the manufacturer. The top of the strap cracks with the repeated depression of the keeper. The strap rotates downward, alternating the location of the lock, shackle, and the keeper, allowing the thrower of the switch lever without remedial lock or keeper. If the above type of switch stands are used with switch and derails are not requiring securing the soundness of the strap, it is not question now, but the track owner requires the stand to be secured by the lock and keep it the displaying of the cracks in which call in the question the soundness of the lateral mechanism, the defective code 213.135.09 thrower level potentially operable switch lock keeper in place should be cited with the recommendation of violation if the track of the owner aggressively adversely corrects the potential defect of the subject type of the switch stands considered the recommendation violation in chief of all times. 135G for each switch position indicator shall be clearly visible at all times. Guidance: examine the condition of the switch point and switch position indicator. Note the unnecessary obstruction of the visibility. The requirement does not mandate that every switch have a position indicator, but merely requires that such a device clearly visible installed on the switch stand. 135H, unusually chipped or worn switch point that shall be repaired or replaced. Metal flow the shall be removed to ensure proper closure. Guidance: the rule does not provide the specific dimension of determining which switch point of the unusual chipped or worn or torn. An accidental incident database indicates that the worn or the broken switch points are largest signal cause the derails within the general category of frog switching and appliances. However, most of the derailments are related to the other casual fractures such as wheel flange condition, truck stiffness, and train handling characteristics. Therefore, qualified individuals must experience to determine whether the switch point are usually chipped or worn. All right, 135I, tongue and plain mate switches which may be designed exceeding Class 1 accepted track maximum gauge limit are permitted in Class 1 accepted track. Alright, guidance. The paragraph provides an exemption of the item of the specified track work the primary use of the pavement in the street road or street railroads which is not designed and does not conform to the maximum gauge limits prescribed in the Class 1 for the exemption of the track. The type of the special work is fabricated with the girder rail, which includes the tram flange way rolled into the rail section. A mate is similar with the frog located within the side of the switch of the equivalent to the straight stock rail. The switch and when they open and curve the guides, the wheels and must be past the mate of the turnout curves inside of the manner similar to the frog guarded rail. Guidance in general. In addition to the considering of the above criteria, inspectors must perform the following when inspecting switches: check and alignment gauge surface, examine the condition of the wear of the switch points and stock rails, see that all the bolts and nuts and counter pins and other fastenings are in place in good condition and are properly tightened, see that the switch points are fit snugly against the rail with the switch are thrown either in position. Request the railroad representative operate the switch to test the lost motion, loose connections. If applicable, examine the rod fastening the connection with the switch point to the switch circuit controller to examine the area are placed in place in good condition. Examine the condition of and support the spring of the power switch machines. Hand-thrown switch stands, including the automatic safety switch stands. Switch stands, machine fastening, the head block ties must be tight and avoid any movement of the plate. Examine the switch lock and keeper. Examine the condition of the switch position indicated with the red note the unnecessary obstruction to its visibility. Examine the heel block fastenings bars in the absence of the heel block and examine the floating heel of the switch point. Examine the seating of the stock of the rails of the switch plates to ensure that the outer tread of the wheel cannot engage the gauge side of the rail and the chairs of the braces do not these rails. The defective particular problem of the travel direction from the frog to the switch of the trailing movement, the grease line of the slightly groves running around the slight angle of the tree to tread on of the stock of the rail can be provided with the inspector, which close about wheel rail interface with the marker that can be found with the area, while the wheel tread of the transition switch rail to the stock rail when found. The inspector should be closely examine the gauge side with the stock rail to make sure the outer edge of the wheel treads are not containing a gauge side with the stock edge. The gauge side of the stock rail. Examine the gauge plate and switch rod. All right, 120. We got 4 more sections till subpart B. 137A, the flange weight depth measured with the plane of the cross the wheel bearing area of the frog on the Class 1 track may not be less than 1 3/8 of an inch or less than 1 1/2 inches Class 2 and 5 track. The guidance of the Association of American Railroad Field Manual, the interchange of rules, state that the wheel condemnable with the flange weight height of 1 1/2 inches or more above the approximate center line of the tread. The American Rail Engineer and Maintenance of the Way Association, or AREMA, portfolio track work plans the point of the flange weight dimension provided with the design Flange weighted depth of at least 1 3/4 of an inch. Therefore, the amount of the clearance between the worn wheel of the high flange and the bottom of the new frog of the flange weighs may be as light as 3/8 of an inch. At higher speed of the worn frog of the flange weigh less than 1 1/2 inches. The wheel flange could be the bottom of the out of the flange weight and the reserve of the serve of the diameter of the frog. Section 213.137a that permits the flange weight depth of 1 3/8 of an inch in a Class 1 track, and such that the condition of the wheel approaching the condemning limits may contact the bottom of the flange weight as such possible to evidence with the flange weight contact of the bottom of the flange weight caused by the non-compliant wheels. 137b. If the frog with point and chip the broken worn more than 8/8 of an inch down and 6 inches back, operating speed over the frog may not be more than 10 miles an hour. Again, if the frog chipped to the broken worn more than 5/8 of an inch down or 6 inches back in the collapsible point of the area, possible repeated wheel impacts, the parameter requires the defect of more than 5/8 of an inch of it down an original profile location 6 inches back toward the heel to be considered. For example, the frog point for 7/8 of an inch below the original portfolio, actual frog point and 7/8 and below the position 6 inches back toward the heel frog would be defective. For several conditions that would not meet the criteria, such as the breakout of the frog point, this is only 4 inches in length, greater than 5/8 of an inch down. Inspectors may consider using defective code 213.137.99, while the condition may not be in defective method of the railroad condition where the inspector feels the structural integrity of the frog is in question. Please note 213.137.99 does not link with the paragraph. Track safety standards may not only be used as an advisory to the railroad. Another possible result of several worn frog point, especially when coupled with a worn or loose guardrail, the railroad wheel may hit the point and climb the wrong side of the frog. And also see Figure 28, information the depressed point, the design that may influence the measurement of the worn or broken frog point. Alright, 137. The tread portion of the frog casting the worn drown more than 3/8 of an inch below the original contour. Operating speed over the frog may not be more than 10 miles an hour. The paragraph specifically referred to the amount of the tread wear for the original contour of the casting. The original contour can be determined a variety of the ways depending upon the frog design. The tread of the frog considered to be inappropriate to be any portion of the contact with the tread of the wheel exempt to the portion of the frog actual or under the position of 6 inches back towards the heel. This area of the dress in statute 213.137b as shown in Figure 28. The measurements of the portion of the tread further back than 6 inches may be taken in place of the straight edge position of longitudinal and transverse. Figure 28 shows the rail-bound magnesium frog designed for the actual frog point that is 3/16 of an inch lower than the tread portion of the frog, built with magnesium, a frog composed of the T-rails called by a bolted rigid frog, with the other point of the similar profile called the depressed point. The tread will taper up in top of the rail profile in the direction toward the frog heel, distance equal to 1/2 the frog number inches, but not less than 5 inches. Alright, here is your diagram of Figure 28. Rail-bound magnesium frog, depressed, point shaped, 6 inches of tread wear measured. This is your point of this is the throat, the wing rail, the treaded area. It shows the cross-sectional view of the stand viewpoint of the original point of the contour, point of the heel to the tread of wear. Keep in mind the ramp is depressed and the point of the frog. Number 12, upon the actual point of the top of the running of the rail provides 1/2 the frog, no inches, and number of inches, and not more or less than 5 inches. Straight edge longitudinal unworn. Alternate rail-bound magnesium solid casting frog design includes the profile whereby the treading portion of the casting adjacent to the frog is manufactured in place, playing 1/8 of an inch to the top of the rail. The profile wing wheel riser. See Figure 29. The design characteristics not to be considered while in measuring the tread wear is discussed below. Rail-bound magnesium risers, tread area, the wing rail, the risers, the tread area, the straight edge of the place transversely against the length of the frog where the tread wear occurs. This shows your straight edge over the tread wear and the 1/8 of an inch rise of the wing rail and no tread wear. When measuring tread wear, the distance of the bottom of the straight edge of the worn tread at the riser of the measure various type of the gauge. This is unfolding the left gauge of the different degrees of taper. The wedge type of the gauge is maintaining the measurement of the type of the tape measures also frequently used to measure the tread wear. If the tread is more than 3/8 of an inch, considering the flange weight depth, may also be reaching the critical limits. Since magnesium inserted with the typical design to be about 2 inches to take at the wall of the flange way, about 1/3 of an inch less than the bottom of the flange way, where the condemning range with it could be resulted It is a structural failure of the frog. Frogs frequently exhibit a small spalling, pitting of the tread. They're usually the type of the spalling is non-hazardous. Measurement of the tree at tread wear should be made over the length of the worn or down due to the abrasion of the plastic flow of the metal at the bottom of the small spalls. However, the depression is sufficient size of the permitted with the tread of the wheel to follow. The depression tread should be measured at the depression. To measure the flange weight depth and base of the straight edge across the frog area, the concerned measuring the space between the underside of the straight edge and the bottom of the flange weight space between the underside of the straight edge and the tread as shown in figure 30. Subtract the tread value and flange weight value to obtain the actual flange depth. Alright, here's the flag point, the straight edge of the tread of the wear, the half-inch tread depth, the wing rail, two straight edges to the bottom of the flange way, the wheel profile. Alright, when rail wheel approaches the frog and facing the direction of the wheel, the weight of the wheel and supported with the tread of the frog opposite the point where the wheel reaches the transition point about 6 inches back of the actual point at the location of the weight of the transverse of the frog point. The figure 137D, where the frog are designed for the flange bearing, the flange weight depth may be less than shown in Class 1 if operated in Class 1 speeds. Guys, the paragraph provides the exemption of the item in the specified track of the work that the design does not conform the minimum flange weightage depth is required as prescribed in paragraph A of the section called flange weightage bearing frog. The technology is under consideration as a method of reducing impact loads at the frog. The design is nearly as a new concept of the track above the yard speed, but it has been extensively in light rail transit track work. The number of the frog designs and used throughout the industry and most of the common type of the rail bound magnesium bolted rigid off stiff. The special attributed with the spring frogs are covered in statute 230 and 139. Conditional movable point frogs are found in the flat angle crossing and split or switches. This type of the movement point of the frog is similar to the switch because the movable points that fit against the knuckle of the rail, which is like a stock rail. Alright, in recent decades, new technology movable frogs have been introduced in the nation. There are two types: swinging nose, figure 32, and movable wing, 33. Conventional movable points of the frog, swing nose for frogs, and virtual switches. Therefore, are no guardrails and such items appropriate to the applicable elements of the statute 213-135 switches. An inspection report with the encountering defects of the movable point frogs, for example, the movable points that does not fit in the knuckle rail properly, can be covered under the statute 213-135B. Each of the switch points shall fit its stock rail properly. Figure 31 shows the knuckle, the rail, and the movable point. The movable wing rail for frog is similar to the spring frog. Both of the wing rails are moved remotely and switch synchronized and switch points is appropriate for the applicable elements of 213-139 spring rail frogs and inspection report encountering defects like above when any of the figures in 139 defect. Codes is necessary to include the defect code 213-133-20. Turnout or track crossing fastener is not indicated but to maintain. Figure 32 shows a swing nose frog, and figure 32-3 shows a movable wing frog look. The following are key elements to be considered in inspection of new technology frogs: bolting and fastener design and that fasten movable point of the frog to concrete, timber, to switch ties, and considered fasteners in smaller and as cut specs. Fastening as discussed in statute 213-127 of this manual, but this contact movable frog component with it together and considered with the frog bolts must be addressed by using the defective code 213-133-12, loose and missing frog bolts. On paramount importance, the proper fitting of the V-vets point of the T against the wing of the rail of the movable frog. The inspectors must use the judgment to determine if the point of the fits the wing rail properly to allow the wheels to pass through the frog point. Movable of the wing rail must have not adversely affected the fit of the frog point to the wing rail. When the inspector encounters the condition of the movable frog, which should be addressed on the inspection report, no existing code is available of the condition of the defective code 213-137-99 will be acceptable for the full description of the condition of the inspection on the report. Unlike rail-bound magnesium frogs, the running surface of most of it is not above the movable frogs that are made of hardened rail. Inspectors must also be aware that the rail may contain the defects that require the remedial action. Under Statute 213-133, asymmetrical rails found in some switch points of the frogs must closely examined during the inspection, as it appears the potential weak spot of the crack or break could occur. When performing inspection, the FRA inspection should discuss and concern with any of the turnout appropriate with the rail personnel. Inspector should consult with the regional track specialist to resolve any of the questions. Safety of these installations, guidance, and general. The various types of the frogs available for the specific applications include bolted, rigid, solid, magnesium, self-guard, rail-bound, magnesium, spring rail, movable point, cast, and swing nose. On rail-bound magnesium frogs, the normal wear pattern is magnesium insert. The inspector, additional with the measurement described in the track safety standards, should see that the frog isn't supported through all well-tampered sound ties. The requirements of flange weight depth, paragraph A. The requirements of tread wear in paragraph C. This all applies to the crossing the frog. So the design flange weight depth is also 1/7/8 of an inch. If your concerns also there, the some excessive wear of the tread portion could also result in wheel flange striking the bottom of the flange weight, causing the structural damage to the frog. Inspectors must evaluate the crack of the brakes and the frog casting, the rail defects of the running portion of the wing rails in terms of the potential effect of the safety passages of the rolling stock, in particular while making the evaluation. The inspector should determine if there is a loss, imminent loss of wheel guidance due to the loss of functional integrity, and the inspector should not consider the brakes of the magnesium frog of the casting if it do not affect the safe passage of the rolling stock to be defective condition. If severe with the crack of the severe cracks or creates the condition, whether breaking out of the piece of the casting imminent with the use of the defective 213-137-99, should consider the crack where was that developed when the loss of the functional integrity should be addressed by using the effective code 213-137-02 and 213-137-03, which governs the frog point and the casting. Rail defects in the non-rutting portion of the wings should be addressed by using the effective 213-137-99. Alright, spring rail frogs. 139, the outer edge of the 213-139 spring rail frogs. The 139A, the outer edge of the wheel tread that shall not contact the gauge of the side of the spring wing rail. Guidance: the inspector must constantly examine every spring rail frog encountered during the inspection. When the spring rail frog has been successfully used for many years, the unique design requires special maintenance attention, avoiding derailment hazards during trailing. The point of the train movements on the main track of the spring wing rail is higher than the top of the frog point. At the hollow wheel, the false flange of the wheel during the trailing movement must push the swing of the rail and causing the extreme wide gauge, while some of the spring rail have the relief of the groove built and for the frog for the purpose. The inspector must acutely aware of all any signs of the signs of gauge side of the spring wing rail being struck in the outer edge of the wheel of the tread. 139, the toe of each of the wing rails shall be solidly tampered and fully tight and bolted. Guidance: the toe of each of the spring rail frog must be solidly supported with the proper hold down of the housing clearance. It must be maintained to avoid excessive vertical movement of the wing rail. This first sign of the occurring will be gouging the gauge corner of the wing rail behind the point of the frog. Wheel gouging must not be confused with the channeling in the spring wing rail incorporated at the time of the manufacture, accommodated with wheel tread transition. If the toe is not solidly tampered, excessively worn with the housing clear existing with the ring rail may have vertical motion operating on the point of the rail, the trailing point of the movement, and the force of the wing rail will cause the wing rail to move laterally along the wheels to drop at the throat of the frog. 139C, at the frog with the bolt hole defective to the head web separation shall be replaced. Guidance: any bolt hole defective to the head web separation in a spring frog of any dimension constituting defect, the spring defect is not prescribed the corrective action of the replacement. 139D, each spring shall have a compression sufficient to hold the wing rail against the point of the rail. Typically, a wing rail up against the point of the indicated with the spring holding is intended. Therefore, the suspicion that it is sufficient with the compression of the spring with the railroad representative shall determine the compliance. 139E, for the clearance between the hold down housing and the horn shall be not more than 1/4 of an inch. Guidance: since the spring wing rail is movable part of the spring frog, it cannot be fastened down. The hold down housing, the horn assembly prevents the wing rail from moving higher than the top of the point of the frog. The figure 35 illustrates the proper method of determining the excess spaces between the hold down of the housing and the horn. Guidance: in general, due to the unique design characteristics of spring frog turnouts and type of the appliances requiring specific consideration regarding the guardrails on main track side of the turnout, whether the trains are not springing on the frog by design operating in an unbroken path. Extreme length of the guardrail ensure with the proper path of the wheel set. A guardrail shall be sufficient length to cover the design of the high hinge and to keep the wheels off the spring of the wing rail from the point of where the rail is hinged through the frog throat, finally through the actual frog point. While the track safety standards does not address the design concept, inspectors should be aware of the attributes of the spring fog. If the guardrail is insufficient with the length of the design, hinge length, and any lateral wheel force, it can cause a significant problem. Special guardrail and other fog elements will quickly deteriorate in extreme circumstances. The wing rail can open while the trains are moving through the main track side, which can cause a result of unprotected wide gauge. Inspectors should note that their inspector report any of the guardrail on a spring fog that is not on the proper length installed in the proper position. Another special consideration regarding spring frogs is the longitudinal relationship between spring wing rail and frog point. The turn out with sufficient rail anchors to the restraint of longitudinal movement. The wing rail may not function properly. Evidence the longitudinal movement occurs with maybe gap between the ring rail and the frog point. Inspectors may be reminded to refer to the statute 213.1 and 33B with required the class 3 and 5 track to be equipped with sufficient rail to inquire the restricting longitudinal rail movement. The longitudinal movement is observed because of the insufficient anchors on class 1 and 2 tracks. Inspectors should be encouraged to note the condition and inform the railroad. Spring frogs are manufactured with steel bases attached with base plates, clip plates, which are placed along the fixed side of the frog. The clip plates are shaped into the right angle and are attached through the base of the bottom by the bolts and welded both. Or both. Frog bolts are in place with the body of the frog through the vertical portion of the clip plates and lighten the holds the body of the frog with the clip plates assembly. There are no gauge holding fasteners along with the move side of the frog, as they would interfere with the spring welding wing rail. Therefore, if it can be seen with the frog bolts clip plate with the assembly acting together and maintaining alignment with the spring frog, care should be taken to ensure the frog bolts and clip plate bolts in place tighten. Defect code 213.133.12. Also check clip plates to see if the welds are cracked, broken. Check clip plates for cracks, breaks, or any corner where the plate bends to the horizontal, vertical, where the cracks or breaks and clip plates affect the passing of the frog to base plate while using the defective code 213.127.01. In recent years, railroads have augmented the design of springs insulation from the application of improved stops limited to the amount of movement of the spring rail. In addition, some of the frogs have been retrofitted with welded stop. Most of the stops are designed to allow the wing to open up more than 1/7/8 of an inch to 2/4 of an inch to 1/4 inch. When stops are properly installed, the risk of the traveling point of the derailment is reduced. When spring frogs are equipped to improve the features of such a relief gate grooves and stops, the inspector should evaluate the condition of the components in order to be certain and that the improved features are functional as intended. When spring frog defects are found, defective conditions must be repaired as soon as possible. Combination of the defects are especially hazardous. Railroads must protect the movement of the frog with the speed restriction until the defects are repaired. Alright, your spring frog detectors is considered with the non-specific defects. See Statute 213.199. Therefore, the inspector must consider the circumstances involved in evaluating the remedial action taken by the railroad. Spring frog defective as found. Inspectors should consider that the spring frog defects are serious, with the most be repaired as soon as possible. In most circumstances, with the outer edge of the wheels in contact with the engaged side of the wing rail, or a combination of spring frog defects, inspectors would be except the railroad would be implemented with a speed restriction. Some spring frogs are equipped with retarders to reduce the impact of the wing on the point of the wing close to the passing of the wheel of the diverging route. The retarders may hang, causing the wing to remain open. That with the traffic safety standards does not address the design concept, inspectors should still be aware of the attributed to spring frogs, but can lead to the further degradation of the components. All right. Moving on to 213.144 self-guarded frogs. 141. The raised guard with the self-guarded frog may not be more than 3/8 of an inch. Guidance. Examining the self-guard, observe the condition of the frog point, whether there is evidence where caused by the wheel flange. Tagging the frog point measurement, determine the compliance with the section, determine the amount of the wear, the raised guard measuring complete thickness and the portion where the wear, and compare the measurement of the portion where there is no wear. The difference between the two equivalent is the amount of the wear. Alright, 141B. If the repair is made by the self-guard frog with removing it from the surface, the guarding of the face must be restored by rebuilding the point. Guys, during the repairs of the self-guarded frog, the imperative that the raised guarding face is restored with the actual frog point. The precaution is necessary to due to the potential of the wheel flange striking the frog point. Self-guarded frogs are designed for use of low-speed tracks. They are used in the track where the speed exceeds 20 miles per hour, can result in excessive lateral force, such as wheels are kicking in extreme, causing the wheel climbing up the raised guard. The track safety standards does not prohibit the use of self-guarded frogs in any class track. However, the inspectors can be encouraged to inform the railroad of potential problems that may occur if the self-guarded track frog is found in a track where it speeds excess of 20 miles an hour. Alright, frog guardrails and guard face gauges. The guard check of the guard face gauge must be in the limits prescribed in the following table: Class 1, 2, 3, and 4. Class 1, 4, 6/8 of an inch guard check gauge, guard face gauge 4 foot 5 and a quarter inch. 2 Class 2, 4 foot 6 and a quarter inch guard check gauge, guard face gauge 4 and 5/8 of an inch. Class 3 and 4 guard check gauge 4 and 6/3 of an inch. 4 and guard face gauge 4 and 5/8 of an inch. Class 5 track 4 foot 6 and a half inches. Guard face check 4 and 5 inches. Guidance: a guardrail is installed parallel to the running rail opposite with the guard from the flange with the rail. The hold wheels of the equipment with the proper alignment with the passing of the frog. A guardrail must maintain the proper relative position of the frog in order to accomplish critical intended safety functions. Inspectors should examine the guardrails carefully to see they adequately fastened when measuring the guardrail gauge. Fully consider any of the movement guardrail frog under the traffic conditions. The section clearly specifies the allowable tolerance of the guard check and the guard face gauge for the various classes of the track. When performing the guard face check, it is important to consider the path of the wheel through the frog, because of the function of the guardrail is to keep the wheel flanges from striking the actual frog. The point, as referenced to standard check gauge of the railway wheel, is approximately 5 to 54 and a half inches. The approximate design check gauge of the values: track safety standard minimum guard check gauge is less than wheel check gauge is less than lower class of the track that is conditioned actual frog point relevant to the path of the wheels from the flat frog to the good, indicated by the effective guardrails. The critical area with a guard face check must be measured to the actual point of the frog. Inspectors must also consider an unusual wear that may exist for the actual frog point and position the track gauge on other measuring devices. Figure 37 shows the flange weight of 1/7/8 of an inch for the guardrail with a wheel check with the track check, and a flange weight about 1/8 of an inch off the point and frog or tread riser on the frog point. When measuring guard check gauge, the dynamic lateral movement of the guard rail and frog shall be considered. In the case of the frog moving lateral under the train movement, the floating, it is important to consider the most restrictive movement, specifically as measuring the guard check gauge and the turnout, whether the frog can be moved toward the tracking measured due to the train movement and other tracks. Dynamic frog positioning will be considered. Alright, main track number 2, guard check guard face gauge, and track number 1, turnout truck, resulting from force or shoves of the frog. This serves the case of when the frog severely floating, move laterally, or there is an accompanying and deteriorating cross ties and effective fasteners. The FRA inspector should cite the defectively recommended by the civil penalty accompanying the condition of, i.e., etc. 213-109, cross ties 213-127, rail fastenings. Face gauge is the dimension that becomes critical with the distance between the two opposing guardrails and the guardrail and the frog wing of the rail, and will become larger the distance between the back of the wheel sets. It would occur with the improper installation on the condition, such as severe alignment. The defect normally face gauge would measure the same vicinity as the check gauge. However, the inspector should be considered measuring the face gauge at the points of the specific visual track, whether they are an indication the wheels are being pinched. And for general reference, Figure 39 illustrates approximate design face gauge values. Figure 39 shows the 1/7/8 of an inch fan way with the wheel face of 4 foot 5 and a quarter inch, with the track face surface of 4 and 4 3/4 of an inch, flange way about 1/8 of an inch off the point, and frog treads riser on the frog point. Broken guardrails occur infrequently since they does not support the vertical wheel load, the passing train, the evaluating crack of the braking, and the guardrail. The inspector should aware the crack of the brake exists, but then does not affect the ability of the guardrail to function as intended. But the integrity of the guardrail is affected. The inspector will cite the defective defect code of 213-143-03, cracked broken guardrail. There are many different types of design from the frog guardrail design. Some of the guardrail plates are recessed to seat the running of the rail, while others are flat. Some of the guardrail plates are sponged with spike hole slots, and others are not. Other guardrails are bolted bolted for the running of the rail. Some of the roads and normal practices, not in the spike gauge of the running of the rail through the guardrail area. With some guardrail places do not have the hole punched with the purposes. FRA has not recorded serious safety problems that have developed as a result of non-spiking running rail through the guardrail area. If encountering the problem with the running rail has been moved laterally to create the unsafe condition, the inspector should insufficiently fasten or is defective code of 213.127.01. Inspector should discuss the unique situation from the regional track specialist. While not requirement of the track safety standard, guardrails have straight position with the guides wheels through the area through the throat, the actual frog point. The inspector should find the guardrail where the straight portion does not encompass the area. The inspector should bring to the attention of the railroad. Figure 40 illustrates the proper measurement point to determine check face gauge compliance and shows the proper longitudinal relationship between the guardrail and the frog point. Figure 40 shows the throat, the critical guard area, the frog point, the check of the face, and the measurement of the face gauges. Check the gauge should be about 6 inches back from the actual frog. The face from the frog point to the outside of the guardrail is the face back-to-back gauge, and the check gauge is from the inside of the other side of the frog point, inside of the frog, the outer check gauge. Subpart E, track appliances and track-related devices.